Hey guys, so I'm here to make your IB lives hopefully a little bit easier by teaching you the basic concepts of IB chemistry SL, okay? And teaching you to answer basically IB style questions. I take SL Chem, so that's the reason I'm not teaching HL Chem. These videos are designed to simplify IB Chem for you and give you basically all the information you need to know without overcomplicating everything. Even if I talk about, even if you find the stuff that I talk about kind of too simple, it's really important you watch it so you get a perfect understanding of the basics. But if it's really, really too simple for you and you find that you are really strong when it comes to the basics of what I'm talking about, then you can just go ahead and watch my other videos about answering IB style questions. So basically, ignore this little thing here. I'm going to try to work around it. Basically, it's a stupid message talking about how this is only a trial, but the program I'm using, I mean. Anyway, hopefully it's not too much of a bother. So the first topic I will discuss is quantitative chemistry. Okay, I notice a lot of people find this topic hard and get really anxious when they hear the word moles. Okay, but I honestly feel it's one of the easiest topics, and hopefully you'll see that too by the end of this video. So let's start off by talking about what a mole is. Okay, so a mole is defined by the amount of, the definition of a mole is the amount of a substance which contains the same number of chemical species as there are atoms in exactly 12 grams of the isotope carbon-12. Okay, don't freak out. I'll explain it in English. Basically, okay, let me just erase this. As you've noticed, I like to write a lot and kind of make little drawings while I'm writing. I'm really a visual learner. Hopefully that doesn't bother you. Okay? So, I like to use an example that, like shoes and socks, these are, just pretend they're shoes and socks, okay? Shoes and socks. Horrible drawer. Okay. Like shoes and socks are counted in, pairs. People say a pair of shoes or a pair of socks. Okay, and like eggs are counted in dozens. Okay, like a dozen eggs. Um, Chemists decided to count atoms, in moles. Okay, instead of counting them in terms of each and every atom. They're just trying to make life simpler that way. So basically this guy Avogadro, let's draw Avogadro. Okay. Woohoo. Okay. So this guy Avogadro, he was this awesome, brilliant man who came up with this idea that 1 mole of any substance contains 6.02 times 10 to the power of 23 atoms of that substance. This is called Avogadro's constant. So just like 1 carton of eggs, okay, contains 12 eggs, 1 mole of, for example, we can give an example, 1 mole of sodium contains 6.02 times 10 to the power of 23 atoms of sodium, okay? It seems fairly easy, okay, sounds really simple, but there are a few tricky questions. Okay, for example, 1 mole of hydrogen gas, does not equal 6.02 times 10 to the 23 atoms, hydrogen atoms. Why is that? Well, basically, okay, hydrogen gas never exists naturally as a single atom of hydrogen. It's always paired up with another hydrogen. So, that's why it's written like this, H2, right? So 1 mole of hydrogen gas actually contains, you have to multiply this number by 2, it actually contains 1.2 times 10 to the power of 24 hydrogen atoms, okay? So, that's pretty simple. These these are exceptions, right? These exceptions are called, wait, let's move down. They're called diatomic molecules. All right? And they include hydrogen, okay, nitrogen, hydrogen, nitrogen, oxygen, fluorine, bromine, oh, we forgot two. See, that's why they're called, and, oops, where did that go? One second. And iodine. Okay, so these are the diatomic molecules. Alright, so whenever you get a question which asks you, for example, how many atoms, oxygen atoms are there in 1 mole of oxygen gas, right? You would always write, you would always multiply it by 2, so you always get 1.2 times 10 to the 24. Alright? So what else is there? We need to talk about, okay, if you have, for example, 2 moles of something, okay, so say again, let's say Na, 2 moles of Na, again you would multiply, it's the same concept as diatomic molecules, right? You'd multiply 2 times 6.02 times 10 to the power of 23, which is, as we know, 1.2 times 10 to the power of 24. Okay? So it's really not that bad. Okay, I don't know what these marks are. Okay, anyway. It's really not that bad. Alright. So now we know how to count the number of atoms in moles. Let's talk about figuring out how much they weigh. Well, it's really simple, and you can figure it out from the periodic table. If you're looking for the relative, it's called the relative atomic mass, you can figure that out from the periodic table. Okay, for example, if you have helium, there's a small number, a 2, and a big number, which is a 4. Okay, it's always the bigger number. Alright, that is the relative atomic mass. So that's really easy, you can always figure it out there. But when you're talking about molecules, you don't get molecules, oh sorry, let's just go back. You don't get molecules from the periodic table. So when you're trying to figure out the relative, it's called relative molecular mass, it's still really simple. You just take, for example, let's give an example, right? If you have NaOH, all you have to do is add the relative atomic mass of each one. So for Na, it would be 22.99. For O, it's 16. And for H, it's 1.01. And when you add it together, you get 40. Okay, so that is a relative molecular mass. Okay, let's give another example really quickly, because it kind of gets, you might get confused here. If you have, for example, this, you add them by, okay, you make a little chart, so C, H, and O, these are the elements you have in, this is ethanol, okay, okay, so the relative atomic mass of carbon is 12.01, for hydrogen is 1.01, for oxygen is 16. Okay, then you write down how many of each is in ethanol, the molecule. So it's 2 of carbon, you have 5 plus 1 is 6 of hydrogen, and 1 of oxygen. So what you do is you multiply these numbers together, okay, and then you add them together. Your final answer should be 46.08, okay, and, okay, sorry, let's push that up. I keep forgetting there's a little notice down here, it's really annoying. Okay, so it's really simple, And then if it asks you, okay, how about when you have 2 moles of ethanol, what would you do for the relative atomic mass? Basically, you would multiply this by 2, and you get 92.16. Alright, so it's really quite simple. Now, if you get a question, alright, this deserves a new page because it kind of combines everything we know now. Okay, so if you get a question that asks you calculate the number of moles in 4 grams of sodium hydroxide, okay, how would you do this? Well, okay, we have a formula. I personally find the triangle really helpful, okay? So what it is, the triangle is the mass, I'll explain it in a second, mass, and the number of moles, okay, the number of moles, and the, what is it? The molecular mass. Okay? So if we're trying to find out the number of moles, basically we see that the number of moles from the triangle equals the masses on top of the molar mass. And what is the mass? We know that the mass from here, from the question, you can get the mass from the question, is 4. And we know that the molar mass of NaOH, we calculated it earlier, is 40. So 4 over 40, which gives you 0.1 moles. Okay, so it's really just as simple as that. You can find, from this triangle, okay, you can figure out either mass, the number of moles, or the molecular mass of anything as long as you have 2 of the above. Okay, so I hope that made sense to you, and please comment if something is unclear or if you have any suggestions about improvement or anything like that. And if you want some practice on IB style questions and moles, you can always watch my other video. So yeah, thanks for watching and good luck on your IB lives.